I need that energy you're using. Use that energy to concentrate and look. Alright. The period is the interval over which the graph repeats itself. Okay? It is an interval such that the graph will repeat itself in terms of the shape. Okay? So you must know that definition of period. It is an interval over which the graph repeats itself. Okay? In physics, the definition of period is the time taken to complete one oscillation. Okay? Right? Now, in maths, the period, its units are degrees. Okay? In maths, the units are degrees. Okay? So it's an interval over which the graph repeats itself. Okay? So let's move on to the basic graph. So you must know the definition of period. Now, if you are going to continue with this subject until trigonometric graphs will continue to pop up, and we are going to expand them next year. Okay? They are expanded in grade 11. And they are tested when you write metric, but they are not taught in metric, so they are only taught in two grades, 10 and 11. Grade 10, that's when the foundation is laid. So if you understand them now, you won't have any major issues later on. So your basic graph for sine, it's y equal to sine x, okay? Which means the q is going to be 0, okay? If there is no number in front here or to the right of sine x, it means q is 0. Also, if the coefficient of sine x is not written like this, it means the amplitude is 1. If the coefficient is not written, it means the coefficient of sine x is 1. So the amplitude of this graph is a 1. Okay? So any sine graph that you are going to encounter going forward, it originates from playing around with that one. Okay? Y equal to sine x. So we just move this graph up or down. That's all. Okay? Now for us to carry on, we need to draw a table of values. Now the trigonometric graphs, when you sketch them, the basic graph, generally start from 0 to 360. But they are periodic, which means they carry on up to infinity. But so we have to restrict the domain. So the main domain is from 0 to 360 degrees. Okay? So we draw up a table of values. First column for x, the second column for the y values. Okay? Can you check out your... Okay? Then end. Now, end is the maximum of the domain. It's 360 degrees for our graph. So you put 360. Then you press equals. Then it says step. Now, this is very important. By step, we are saying, if you are starting from 0, what's the next value of x? Okay, for this graph of sine, the step is given by a formula, but you just have to memorize the step. Okay, the step is equal to 360 degrees divided by 4, and that gives you 90 degrees. Okay, so your step is 90. You put 90, then you press equals. It gives you the table. Okay? What? You start at 0. Put 0 and press equals. And then end 360 and press equals. Okay? Like the quadratic function, the hyperbola, exponential, use freehand. So, the first thing that you have to do, If x is 0, that's here. Y is 0. So that's your first point. We are plotting now. Then if x is 90, y is 1. That's the point there. Then when x is 180, it's this point. When x is 270, y is minus 1. And when x is 360, y is 0. So if you put these values where there is x here in the equation, you get those y values. Then you use freehand. Okay? You draw nicely like that. It requires some experience, so you have to practice as well. Okay? It's freehand, no ruler. You're not supposed to use a ruler. It's freehand. Okay? And then you get your what? Your graph. Now it's very important for you to pay attention now because I need to talk about the concept of amplitude again from a graph. Because there are, in a test situation, you can be asked to determine the amplitude from a sketched graph. Okay? I just want to remind you, this is the basic graph. Okay? So the amplitude is also the distance from the x-axis to the maximum turning point. Okay? The distance from the x-axis to the maximum turning point is also the distance from the minimum turning point to the x-axis. Okay? Now, the definition that I gave was based on the distance between the maximum and the minimum. So the maximum value here is 1. The minimum, I'll give you a formula later on for this. The minimum is minus 1. Okay? I think I gave you a formula where I said y max minus y minimum. I gave you. Am I right? When I'm doing algebraic functions. Yes. The vertical distance is y max minus y minimum. The horizontal distance is x maximum minus x minimum. I gave you that. Okay? So we can use that as well. Because amplitude is a distance. So it's equal to y max, which is 1, minus y minimum, which is minus 1. So 1 minus minus 1 gives you what? A 2. But that's not the amplitude. Okay? This 2 is the distance between the maximum and the minimum. The amplitude is half that distance. So to get the amplitude A, you divide that 2 by 2 and you end up getting 1. So your amplitude is half the distance between the maximum and the minimum value. It is also the distance from the x-axis to the maximum turning point, or from the x-axis to the minimum turning point. It's a distance. It's never negative. Okay? Because in the past, I'm telling you from experience, some learners, they get a question on amplitude and they put a negative value for the amplitude. If you do that, it's not me who taught you that. Amplitude is always negative. It's a distance. Okay? No, it's always positive, sorry. Right? The amplitude is always positive. Okay. Alright, so make sure you're aware of that. So any graph of sine that you are going to encounter, any graph in this grade, it originates from this graph. We can draw it beyond 360, which means we extend and it becomes periodic. It can go on up to infinity. We can even draw it on the negative side of x. But in this grade, we only concentrate on positive angles. Okay? The negative angles, that's for grade 11. So we start from 0 up to 360. Okay? We don't want to complicate things for you because you are still in grade 10. Okay? So that's your basic graph. Now, there are some key things here that you need to be aware of. Number one, the period of the graph is 360 degrees. Okay? I'm going to repeat again. Period is an interval over which the graph repeats itself. So after 360 degrees, this graph will repeat itself. Every 360 degrees, it repeats itself. The amplitude is 1. Okay? I've shown you how to get the amplitude from a given graph. You can also get the amplitude from the equation. The coefficient of sine x, if it's positive, that's the amplitude. If it's negative, then you take the positive of that coefficient, like this. If you are given the function as y equals minus 2 sine x, like this, it doesn't mean that the amplitude is minus 2. The amplitude is 2. It's always positive. So you take the positive of that coefficient. So your A will be 2. When I say A, I'm referring to the amplitude. Okay? So that's the sine graph. Okay? Now I need to move on to the cosine graph. Now the cosine graph has a relationship with the sine graph. Okay? In actual fact, the cosine graph is the sine graph after shifting the sine graph to the left by 90 degrees. So if you move this graph by 90 degrees to the left, this maximum turning point, it moves to the y-axis. Okay, this point, it moves to that point. And we end up having a new graph which is called the cosine graph. Always remember that sine and cosine, they are related. Okay, sine and cosine are related. That's why if you understand sine, you should also understand cosine. Okay? Okay, so this is the graph of y equal to cos x. Okay? To get this graph, all we did was shift the graph of sine by 90 degrees to the left. Okay? What that means in mathematical terms is like this. Okay, let me write it on the board. Here. The graph of cos is like this. You have got cos x. It is the same as sine 90 degrees minus x. Okay? Right? But for now, because we are in grade 10, we don't want to get into the details of that. Okay? Or we can write that as, okay, let me not do it because I don't want to confuse you. But you must know that this graph of cosine, you get it by shifting the graph of sine by 90 degrees to the left. Okay? So if you move the graph of sine by 90 degrees to the left, you get this new graph. It is called the cosine graph. Now, the properties are almost similar. Okay? The only difference is that the graph of sine starts at the origin. This one starts right at the maximum value of y. Okay? So the way that I did the table for sine is the same as for cosine. Okay? So the period of this graph is 360. The amplitude is also 1, because the maximum value is 1 here. The minimum is minus 1. Okay? So your amplitude is also 1. And for the cosine graph, the amplitude is the distance from the x-axis to the minimum turning point. Okay? It is also the distance from the origin to the maximum turning point. Or we can say it is the distance from 360 from the x-axis here up to the maximum turning point. But I prefer you use the other way, that is from the origin to the maximum turning point. That's your amplitude for the basic graph when it's not shifted. Okay, when it's shifted, it's better to use y max minus y minimum. Then you divide that by 2. Okay? Don't worry, I've got an example where I'll talk about that. So you must have your table, then you sketch the graph of cosine of x. Right, let's carry on. Okay, if you're still copying, then carry on. Then let's move on to examples. Right, sketching sine and cosine graph. That's the next heading. Sketching sine and cosine graphs. Okay, so here I started with the graph of sine. Okay, I want you to be aware that I started with a case where the amplitude is 1. Later, we'll make the amplitude 2 or 3 and so on. Okay, so we have a function f of x equal to sine x plus 1. So we are moving the basic graph of sine by 1 unit up. That's what this means. So we're just moving the basic graph of sine by 1 unit up. Okay, so you can put that equation in your calculator. Okay, let's do the exercise now so that you see how I got that. Now, if you put the equation in your calculator, can I have your attention, please? Take out your calculator. So we are going to clear that. Then I'll just add 1 to that equation. Okay? Can you do it as well? You saw how I did it. I just pressed all clear, then the table was clear. It went back to the original equation. Because I already had sine x there, I just have to add 1. Okay? If you don't have, then you start from scratch. In fact, let me start from scratch. So mod number 3. Our graph is sine. Then you press alpha, x, close the bracket. Then you add 1. Okay? Please do it. Do it. Then you press equals. We are starting from 0 degrees. And we are ending at 360 degrees. Okay? Our step is still 90. Any graph of sine and cosine. What do we do with 360? You press equals. No, then it says stop. 0. We are starting from 0 degrees. Okay? And we are ending at 360. Your step is 90. So for all graphs of sine and cos in this grade, you use a step of 90 degrees. So put 90, then you press equals. It gives you the table. Okay, which is the one that I got there. Okay? When x is 0, y is 1. So we have got that point. Okay? When x is 90, okay, y is no longer 1, it's now 2 for this graph. When x is 180, y is no longer 0, it's now at 1. When x is 270, y is no longer minus 1, it's now at 0. And then when x is 360, y is no longer 0, it's now at 1. Okay, just allow me to recalibrate this. Okay. All right. So you must have that. Then you take your pen or your pencil, freehand, you join the points. Draw a nice smooth curve. Like that. Free hand. So you have to practice how to draw. Okay? No ruler. Please. No ruler. Don't be tempted to try and use a ruler. You draw the graph freehand. Okay? So you have your table there, then you have the graph. Now let's write down 5 important things there about the graph. The first thing, the period is 360. Okay? So if you get any question in this grade asking for the period of any sine graph, your answer is 360. You don't have to stress and start thinking what answer should write. 360 degrees. The period will only change in grade 11 and 12. For now, it's 360. Your amplitude, you can get it by looking at the equation. The coefficient of sine x is not written, meaning it's equal to 1. So your amplitude is 1. Okay? Or you can just use the formula A is equal to y max minus y minimum. You can use that for the amplitude. So your maximum value is 2. So you put 2 there. The minimum value is 0. 2 minus 0, okay, it's A equal to y max minus y minimum all over 2. Please, the amplitude is given by the formula y maximum minus y minimum all over 2. Please write that down somewhere in your method. The amplitude is given by the formula y maximum minus y minimum divided by 2. Okay? So our maximum is 2, minimum is 0. 2 minus 0 over 2 will give you 1, which is consistent with the equation. Okay? Then you may need to know, or you may be requested in a test to write down the range of the graph. Remember, what's range? The set of all the y values. So when you're writing the range, you start with the minimum. Your minimum is 0, your maximum is 2. So it will be 0 is less than or equal to y, and y is less than or equal to 2. Now for trigonometric graphs, both the lower limit and the upper limit are included. Okay? For sine and cosine, when you write the range, the lower limit and the upper limit are included. That's why you have to put equal signs here. And that's why you have to put square brackets. Okay? When you're writing the range for sine and cosine, the lower limit and the upper limit are included. Therefore, you use your inequality sign with an equal sign. You use your square brackets. No circular brackets when you're writing the range. Okay? So this is how you write your range. Okay? So make sure you are familiar with what I just did here.
So what is the relation next to y?